Hi, I'm Philip, and in this video I will show you how I fix my lawnmower. So basically, here you see the scan of the lawnmower I will use for the reverse engineering process. And as you may can see, there is quite a big hole here in the frontal plastic shell. And directly behind this is like the axle and the mechanics used to adjust the height, the cutting height. And currently through the hole there is like all the time a bit of like cut grass and other foreign bodies coming in. And these sometimes cause a bit of a problem with adjusting the cutting height. So I just want to generate some kind of plug I can put over this hole. Why I'm here in the scan software, so I use the Rigil, the Einscan Rigil for scanning in like scan standalone mode. You can see I just placed a few of my marker geometries around the body, or around the lawnmower, and they were enough for scanning. So I scanned at 0.5 millimeters in marker scan modes, and this worked fine. But I want to show you, or I'll give you advice on selecting the settings for meshing. So this is like when you mesh, you have like the different options for unwatertight, semi-watertight, and watertight. So if you want to do reverse engineering, I personally would advise always to use the unwatertight, because watertight automatically closes holes and basically generates data you don't, not actual scan data, but it just fills holes and fabulates new data. So this may be maybe not good for reverse engineering. Also, I disable the marker hole filling. So on this part, it actually isn't much of a problem because there are no actual markers on the object itself, on the lawnmower itself. But for me, this is just best measure. So now let's have a look at the scan result I will work with. So this is just loading, and this is the final meshed file, and you're quite nicely seeing the hole. And basically let's start with the preparation of the scan. So before reverse engineering, I always do a scan preparation just to orient the part, delete chunk data, and so on. So because the scan isn't too large with 1.8 million triangles, I actually wouldn't need to use the polygon reduction, but I just do it because this is like the default setting above, I would say, I think 2 million polygons. And the next is, currently we're having quite a lot of individual meshes. I just want to delete like the free floaters here in the back. With other tooling, or if you have like one solid body, and all just small other floaters around, you could just use the leave only selected submesh option. But because here we have a few multiple meshes, I won't be using this. Also the hole filling, it's not needed, but for example, if you want to fill the large hole, the small holes, just use this measure tool. Then you select the hole size you want to fill, you just pull it large, and then use the fill hole option. And as you can see, it filled like the small holes and the small floaters here. Okay, let's move to the next step. Now we could define a symmetry plane. We're not having one here. And now we can already start extracting primitives used for alignment in the next step. We always need 3 primitives for alignment. So basically 3 planes. You could also use different primitives, like you could use a cylinder. You could use, I think, also a sphere as like the origin. But personally, I nearly all the time use 3 planes, or maybe 1 cylinder and 2 planes. So here, the first plane will be the floor. Like this. We can also have a look at the analysis function. Let's select 0.4 millimeters. You're seeing this is like a concrete floor. Then the next plane will actually be here, this interior of the wheel. And then we need a third plane, and I guess for the third plane I will be using just this front side. So as you can see now, the plane is actually a bit angled to the side. It's not too bad if we later use it in the next step for alignment as the last plane. So we only basically need the intersection point of the plane, not the whole plane. So it's start alignment with the floor, then side of the wheel, and then now the plane. And this looks quite fine, so we can hit apply. Maybe first let's start. What you can also do is you can mess a bit around with the alignment functionality here. Like if it's the top plane, the first selected plane is the top plane, or the right plane. There are a lot of options, but basically you select the first one defines the z-axis, the second one defines the y-axis, and the third one defines the x-axis. So I hit apply and this looks quite fine now. I hope you can forgive me. I initially tried to record my my commenting while modeling, but this didn't produce a great result because I couldn't really focus on the reverse engineering, and I normally hear music, so this is quite comforting while doing so. And trying to comment on my approach while thinking about the approach is a bit difficult. So I just decided to let it be, and I just did the whole reverse engineering, and now I can give you a whole short commentation about it. And at this point, please don't forget saving your reverse engineering project. So I thought about, why should I save it? It's not too big, and then I messed around with a few settings for like very extreme draft extrusions, and it crashed Quicksurface. So this is my own fault because I didn't save, and luckily I know the reverse engineering approach and could recreate it quite quickly in the same way. So to start off, I want to get the outline of the hole. For this, the best approach is using a 3D sketch, as I did here. And let's adjust the color of the sketch so it's a bit more visible, like this. And as you can see, I didn't fully put the sketch on the edge of the hole because I want to have a nice surface I can put the sketch on, because it basically snaps to the mesh, as you can see when I'm moving around. What I can later always do is offsetting the surface generated from the sketch. So just try to get a uniform rim, a uniform distance to the hole, then you're fine. I also intentionally created a flat spot here at the bottom because I want to 3D print it. And for this, like having a flat spot is the easiest, because then I have a nice surface to place the part on. Because I will need 2 offset walls from this sketch. So basically, my goal is to extrude the sketch, then offset it a bit to the inside of the hole to get like the outside of the hole, the outline of the hole, and then extrude it a second time to get a rim around the part I can use for gluing on the final part. For this, I just copied the sketch. So basically, on a sketch, you right-click and then duplicate, because you can only extrude a sketch one time. So if you want to extrude it a second time, you need to duplicate it. Extruding the 3D sketches is a bit hidden, and basically you select the sketch, right-click and select extrude. And here you can use like the normal extrude functionality, and it extrudes it to basically, I think it's like the normal of the average plane through the 3D sketch. So this is my best idea of how it is determining the direction to extrude. And for like these slightly curved surfaces, it's quite fine. But what you can always do is using a draft extrusion, so it's a bit fitting a bit better to the surface. So now what I then did is I extruded both sketches. So now I have 2 extruded surfaces, and I offset the surfaces. So the first one is offset to the center, so it is roughly within like all the outlines of the hole. You can see here in the corners, I'm a bit inside, but I will apply a fillet to the corner, so that's not big. Here we have like remnants of marker geometry, and here at the top I can just shove it in. So in the end, it's always already a broken plastic part, so it's easier for me to, if it doesn't fit, just maybe apply a bit of pressure. This also, from my experience from part of seen in real life, this is most likely like some remnants, some very thin plastic piece I can just remove. Then I offset the second sketch to the side. I just made sure I have like a 5mm rim for applying the glue to secure the printed part. And now is the actual interesting part. So let's hide these two surfaces. I need a nice fitting plane to cover the hole and also to fit on the lawnmower itself. And for this, I just use a fit surface. And if I now go on the fit surface, I can analysis. I use the analysis functionality and maybe to a 1/4 millimeter. And it looks quite good. We have like these short, small, low and high spots here where the plastic parts meet or the plastic extrusions meet. This isn't very much of a problem because I will be gluing the printed part on the lawnmower anyway with a very thick glue. So I calculate roughly a 1/2 millimeter of glue. So this is accurate enough. For generating the fit surface, I can give you a short demonstration maybe, because this is, I would say, the most interesting part here. You just select fit surface. And what you can also do, or what I normally do if I want to fit a surface on like one part, so I just use like this magic mouse button. Then I use slider to select the fit band and fit the surface. And here it's, maybe you need to adapt it a bit so it's fitting better. So this looks quite fine. But what I'm doing here, I want to explicitly fit the surface around the outside of the hole. For this, I just use this freehand selection tool. So this is a bit of like a marker. And then I make sure that the select through is turned off, because if select through is turned on, it would also select like the backdrop here. And now I can just sketch around the hole like this, maybe here on the bottom a bit, here on the side, and then this part, so the bridge is also captured. To unselect part, you need Control and Alt, and you get this small minus sign. And then I can fit the surface, and as you can see, it quite nicely fit over this hole. And I would also say it's quite a natural shape now. But I don't want to keep it because I already have the surface. So I have it here. And the next thing is what I'm doing is I'm offsetting it 1/2 millimeter to the outside, because I'm having the glue gap, and this will also help me like closing the small imperfections, because I'm not seeing much of a reason to like spend useless time in getting it to a higher degree of detail than I need. And what I now can do is duplicating the part, duplicating the surface, because I will need one extrusion to the inside of the lawnmower with like the inner cutout, and then one extrusion to the outside with the cutout for the gluing lab. And to duplicate such a part, you basically go to CAD, move body, and there you can create a copy. Basically, it's translation without translation, only creating a copy. Then it first generates a linked copy, so they appear as one surface here. And what you can do is just right-click, and then there is a button, separate bodies or separate surfaces. And then you have two completely independent surfaces you can do different stuff with. And the stuff I'm doing with, so here I'm moving it to have the linked bodies. I can here have the separate bodies. And after separating, you get the two surfaces. And basically, the first one I'm thickening to the inside. I'm thickening to the inside by 2.5 millimeters. The second one thickening to the outside, and now I can directly apply trimming operations. So for trimming, just select the parts you want to trim. So the surface to the outside, then the control button, and now the surface to the inside, the cutout for the outside. And here you have the trim button. And the trim result will look like this. Then the same applies for the inner one. And the last thing I'm doing is combining these two parts, and basically you select both of them and then you have the combined selected solids. And now let's hide the mesh. And the last thing I was doing is applying, two fillets, so one here to the inside, so these are a bit rounded, and the second one to the outside, so I have a bit more of a pleasing surface. And what I now can do is I can directly export it and import it to my slicer, so you can see sorry, what's the best approach for printing. So here I have the cover. I'm printing it from PETG to PETG on my Creality K2. And now let's just use the select or lay on face. And here it's quite handy that I'm having this straight face on the bottom. And what I will also make sure is I will be using a brim on the outside, an outer brim without any gap to the object. So this just makes sure that the brim is really attached to the part, because this is still quite a small contact area. And what I'll also be using is, let's first try out if it's slicing nicely. And the contact area looks fine. And actually, due to the fact that I'm having the support here in the bottom, it's quite well constrained. So I can just send it to my printer and get it printed, and I will show you the final fit part when I come around attaching it. So I just finished, or the part printing just finished, and I would say it looks quite nice. And now let's attach it to the lawnmower. Print is finished, and now I'm having here like the hole I talked about. And let's have a look at the fitment. I would say this fits quite nicely, and now it's time to glue the patch in. And fits good.